Hi, so I am Igor from Zerapool, and I will tell about solving Vitalik's trilemma with zk-driven data availability and storage. Let's talk about Vitalik's trilemma. We have three properties of the blockchain: scalability, security, and decentralization. And the trilemma means that we can select only two of these three properties of a decentralized ledger system. Why we need to solve the trilemma? For mass adoption, we need more scalability and decentralization, keeping the security, and transition from Web 2 to Web 3. We can observe this transition, for example, in Farcaster, but I hope we will see a lot of new Web3 applications for problems which was solved by Web2 way in future. These are historical approaches to solve the trilemma. The first one is multi-chain ecosystem. This is Cosmos and Polkadot. The idea is to maintain core engine and build blockchains on top of it. Due to the same core, these blockchains can interact between each others, and developers can deploy application-specific chains and reach scalability by this way. The next the approach is Plasma, and evolution of Plasma is optimistic rollup. Another direction is the rollup and the Validium, and the last one is data availability layer and modular approach to build decentralized systems. So why rollups are not enough? Because rollups scale the computations but don't scale the data. Data flows to L1. If we have rollup on EVM, we should publish the data of blocks on cold data or on dunk sharding or on data availability layer. And if we deploy rollup inside rollup, anyway, the data will float up, so we will get no advantage from this construction. That's why L3, L4, and so on currently is not so popular approach how to build it. Anyway, we have a bottleneck on the top layer of blockchain. We need recursive rollups. We need solutions how we can deploy rollups inside rollups with no bottlenecks. Then we can build decentralized network of rollups and scale everything. Let's take a look on storage-centric approach. There are long-term storage solutions like Filecoin, R-Wave, and DA&Storage. Let's think how we can store the rollups blocks. Filecoin can store really huge amounts of data, exabytes of data, but out of the box it's not suitable for this problem because the decentralized sequencer has different leaders in different times, and if all parties of storage contract will collude to process denial of service attack, then the data could be unavailable for some time. Not all data, but some of data is enough. R-Wave provide security warranties of data storage on consensus layer. So we should not select data providers by ourselves. For storing the rollups blocks is better because if we have malicious leader of rollup sequencer, he cannot collude with blockchain consensus. And if the rollup sequencer will send something to the network, it will be stored. But R-Wave storage is permanent. And for really scalable rollups, it's not good because we have a lot of transactional data, and if we sometimes send to the blockchain the snapshots, we want to forget everything before the snapshot because we don't need this data to make transactions, and we cannot do it in R-Wave. E-storage is a programmable solution, so users or smart contracts or decentralized protocols can select the rules how to pay and maintain the data in the network, and it's possible to use for long-term data availability. But out of the box, we have no ZK oracles here to make this storage possible to use in multiple rollups, in network of rollups, and also all these solutions are based on replication. So if we want to store the file, we make a lot of copies of this file, and we hope that at least one copy is stored, and that's it's okay. Read Solomon codes are more efficient for this problem. If we want to store something with really high soundness, we can use read Solomon codes, and the disk utilization in this case will be about 10 times more efficient because for read Solomon codes it's enough to get just the same amount of information as the source information, but it doesn't matter which part of the information. Anyway, we can recover the source information. So for storage-centric solution of the Vitalik's trilemma, we need two improvements: read Solomon codes for data sharding and all-chain provable ZK proof. So with the first improvement, we reach 10 times better disk utilization, and with the second, we can build ZK oracle that the data is stored and available, and this ZK oracle could be used inside the network of rollups. We can join it with execution ZK proof of rollups, and then we get the proof with everything rollup needed, with the proof of execution, proof of data availability and storage. Let's talk a little bit about read Solomon codes. For example, we have 4 numbers. We can represent these 4 numbers as polynomial degree 3. Then we can blow up the data and compute another 4 numbers. Then, if we forget the half of these numbers, anyway, we can reconstruct the polynomial, because 4 points are enough to reconstruct the polynomial degree 3. And next, we can recover the source data. This approach is much more efficient than just copy the data of the points a lot of times and hope that each of these points is stored somewhere at least once. The issue of read-Solomon codes is that we should prove that each shard is valid part of the whole commitment of the data. We can represent the data as bivariant polynomial, and then we can easily compute the commitments to shards and prove with this polynomial equation that each shard is a valid part of the source data. And by this way, all nodes could be sure that they received the correct data, and the user can reconstruct the source data if the user downloads enough shards. For example, if we have 64 source shards, we can blow up it to 512. And if we have any 64 available shards, we can recover the source 64 shards. So let's take a look on the key-driven data-centric rollup. We have data availability contract on L2, and it could be proved and verified by the key snarks. The proof of data availability and storage could be merged with the rollup proof, and by this way we get the full proof of state transition and data availability, and this rollup doesn't require any data stored outside of it. This is some parameters what could be reached on a single data-centric rollup. Storage cost could be about 15 cents per gigabyte per year if we use something like Hetzner data nodes. If we use specialized rigs, it could be cheaper. Soundness is 110 bits. That means that if half of network is malicious and perform attacks to deny the service, we have this probability to in order minus 110, then we forget something. And capacity could be more than petabyte. And the main thing here that rollup recursion is unlocked because we don't need any bottlenecks on L1, and rollup can store its blocks data by itself. So question, could we reach more scalability? And the answer is yes. We can build the network of rollups. On the top layer, we can decide on the consensus layer which node is belong to which rollup, and in third layer we have the same petabyte data rollups. We make modeling of attacks on the system, and we find that it's enough to make two mixings between these nodes when some node is going offline to prevent concentration of malicious actors in one segment of the network. And Our estimations are security estimations are valid also for this decentralized solution. By this approach, we can reach universal data layer for applications and rollups, and it could be used for Web 2 to Web 3 transformation. We don't need any specific parameters of security for data storing, because more than 100 bits security is safe for the data what should be stored with very high trust, like financial data. But if we make blow up lesser than 8, for example 4, then the security will be low enough for the data like tweets in Farcaster. So it's growing very fast on blow-up factor. That's why in our engine it is better to fix these security parameters and store safely everything. Due to scalability, the system could be scaled more than exabyte level, and with such network of rollups, not only Farcaster is possible, but decentralized Instagram, YouTube, and so on. Thank you for attention. There are some our write-ups, and now we have a toy model. This is world first rollup with storing its blocks inside itself. That's all.